Now let's move on to question which are of marks 2 that came in previous year GATE exams, and the topic that's going on here is treatment of water. So the very first question which came in GATE 2020 that we are going to discuss is surface overflow rate of a primary settling tank is 20,000 liter per meter square per day. Kinematic viscosity of the water in the tank is this much. Specific gravity is this much. Acceleration due to gravity this much. Minimum diameter of the particle that will be removed with 80% efficiency in the tank. Asking about minimum diameter of the particles that can be removed from the tank, right? Now let's understand what is the concept behind this question. So the very first thing that comes in our mind, that what is surface overflow rate, SOR, that we denoted in short, or it is denoted by V naught as well. Surface overflow rate, or sometimes it is written as surface loading. Now see, what is surface loading or surface overflow rate? Is equal to, that means V naught is equal to discharge upon surface area. Discharge upon surface area. So if this is a tank, right? So this is the upper surface. This is the upper surface of tank, right? This is the upper surface of the tank, and this is made up of, see, this is the length of the tank, this is the width of the tank, and this is the height of the tank, right? This is a rectangular tank. We are talking about rectangular tank. So this is the length, width and height. This is the surface area. So the surface area is made up of length and width. So surface area is nothing but L into B. Now surface overflow rate, that means V naught, is simply discharge upon L into B, right? Discharge is in meter cube per second and area is in meter square. So this surface overflow rate comes out to be meter per second. That means surface overflow rate or the surface loading is nothing but the velocity. It is a unit of velocity. And velocity, what does velocity do? What kind of velocity is this surface overflow rate? So it is defined as the flow velocity at which the sedimentation tank is designed to operate. What does it represent? It represents that if this much velocity, if V naught velocity we provide into the loading rate, if we provide the loading rate at V naught velocity, it will make sure that all the particles will be settled down, that can be removed 100% removal efficiency. That means this surface overflow rate represents that settling velocity of the particles that can be removed at 100% efficiency. So this says that if we put the settling velocity of the particles as V naught, then we can say the particle will be removed 100%. This is what a settling velocity does. Settling velocity or surface overflow rate. Settling velocity, we all know. What is settling velocity? Settling velocity is the velocity at which the particle will settle down, and settling velocity depends upon the diameter of the particle. The formula for settling velocity is gs minus 1 d square upon 18 nu. Nu is nothing but mu upon d, right? So mu upon rho. So rho gs minus d square upon 18 mu is also a settling velocity formula. So we can say settling velocity depends upon the particle specific gravity, the viscosity, the diameter of the particle specifically, right? So settling velocity is this thing. Now, so we say by surface overflow rate, if the settling velocity becomes equal to SOR, the particle will be removed 100%. So, but for particle having settling velocity, when we say particle is having settling velocity equal to surface overflow rate or greater than surface overflow rate, greater than or equal to surface overflow rate, it will definitely settle down, right? Settle down. But what if the settling velocity of the particle is less than surface overflow rate? Then we know that if this particle is having surface velocity less than SOR, we know that it will not be removed. So from that we can say the percentage of particle that will be removed, percentage of particles that will be removed will be equal to Vs upon V naught into 100. So the particle percentage that will be removed will be Vs upon V naught into 100. So now we know that if settling velocity is greater than or equal to surface overflow rate, 100% removal of particles. And if we want to know when settling velocity is less than SOR, then how much percentage of the particles will be removed? It will be this much, Vs upon V naught into 100, right? Okay. In the question, they are asking that for 80% removal efficiency. Okay, the percentage removal efficiency is 80%. Okay, let's calculate first of all Vs, settling velocity, that is gs minus 1 d square upon 18 nu. G particle specific gravity is given as 2.64. G is equal to 2.64 and small g is equal to 9.81. Nu is equal to 1.01 into 10 to the power minus 4 meter per second, and they have given that efficiency of removal is 80%, right? So we can say that Vs upon V naught into 100 is equal to 80, right? From here we can say that Vs is equal to 0.8 into V naught, and this V naught can be calculated out. How? So the V naught is nothing but surface overflow rate, that is discharge upon area. Discharge is given, that is 20,000. Discharge is 20,000 liter per meter square, right? Liter per meter square per day. So see, they have given liter per meter square per day. That means simply they have given the surface overflow rate 20,000 liters will be equivalent to 10 to the power minus 3 meter cube per meter square per day, that is nothing but meter per second, meter per day. So, and per day is also going to be changed to second. In a day there are, per second, in a day there are 86400 seconds, right? So the answer comes to be 2.314 into 10 to the power minus 4 meter per second. Now if V0 is known to us, Vs is equal to 0.8 times of V0, that is 2.314 into 10 to the power minus 4 meter per second. 0.8 into 2.314 is 1.85 into 10 to the power minus 4 meter per second. Now we know Vs. They are simply asking us about the minimum diameter that can be removed. Vs we know from the formula, Vs is equal to Gs minus 1 upon 18 nu into d square. From here d square is equal to, or simply we can say d is equal to under root of Vs into 18 into nu divided by Gs minus 1, that is under root Vs is 1.85 into 10 to the power minus 4 into 18 into nu. The value of nu is 1.01 into 10 to the power minus 4, 1.01 into 10 to the power minus 4 divided by Gs. Gs is 2.64 minus 1, that is 1.64. So the diameter that comes to be is 1.446 into 10 to the power minus 5 meter, that is 14.46 into 10 to the power minus 6 meter, that is 14.46 micrometer. So do we have the option? The answer we need to give is in micrometer, that is 14.46. So the answer is 14.46.